Hi everyone, this is Kanika, and in this video we are going to discuss an easy LeetCode problem, which is word pattern. So this problem is based on string. We are given a pattern and we are given a string s, and we need to check whether s follows the same pattern or not. So here follow means a full match such that there is a bijection between a letter in pattern and non-empty word in S. So what does this mean? This means that we need to check whether there is one-to-one mapping between each letter of pattern and each word of string. So each letter and each word of string, we need to check whether there is one-to-one mapping or not. Let's see our test cases. So in this test case, the pattern given to us is A, B, B, A, and the string given to us is dog, cat, cat, dog. So in order to check whether the string S follows the same pattern or not, we need to check whether there is one-to-one mapping between these letters and these words. So here A is being mapped to dog, A is being mapped to dog. Then again B is being mapped to cat. Then second time when we encounter B, we see that B is again being mapped to cat and A is again being mapped to dog. So there is one-to-one mapping. So A is being mapped to dog and B is being mapped to cat. There is one-to-one mapping between the letters of pattern and between the words of string. So we'll return true in this case. In second test case, there is a pattern A, B, B, A. So A is being mapped to dog. This is fine. B is being mapped to cat. This is fine. So again, when we encountered B, B is being mapped to cat, which is also fine. But here A was being mapped to dog initially. But now when we encountered A is being mapped to fish in this case. So A cannot be mapped with two different words at the same time. Therefore, we'll return false here. Let's see another example. Here the pattern is A and it is being mapped with several different words. So this cannot be possible. So hence we'll return false here. Alright, so in order to discuss the implementation, we need to check mainly for the two cases. One of the case can be that a letter is mapped with two different words. Like in this case, B is mapped with cat, B is mapped with fish, which is not possible. And second case can be that two different letters are being mapped with the same word. For example, A is also mapped with dog and D is also mapped with dog. So this cannot be possible. So first case can be that a letter is mapped with two different words, and second can be a word is mapped with two different letters. So both of these cannot be possible. Okay, so let's discuss the approach for this test case which is given to us. First thing we'll check is whether the length of the pattern and the string array is equal or not. If they are not equal, that means there cannot be one-to-one mapping between them. If they are equal, then we'll proceed further. We'll maintain a hash map of characters and string to store the letter of pattern and word of each string array. And we'll maintain a hash set as well. Initially, a hash map and hash set would be empty, and we'll start traversing from this character. So we'll check whether this character is present in hash map or not. Since this is not present, so we'll add it to a hash map and we'll add this value to our set. We'll see a separate test case to understand why we are maintaining a set as well. So first let's focus on this test case. Now we'll traverse further. We'll check whether this character is present in hash map or not. Since this is not present, we'll add it to our hash map and we'll add this value to our set. Third time when we encountered B, we check that whether this B is present in hash map or not. Okay, so this time B is present in the hash map. So we'll check for its value, whether this value and the value at which we are currently in the string array. If both these values are same, then we'll traverse further. So in this case, these are same. We'll move further. We'll check whether this character is present in hash map or not. Since this is also present, we'll check for these values, whether this value and the value for the character present, that is this particular value, is same or not. So in this case, value is not same. Hence, we'll return false from here. So this was a case in which a single letter is mapped with two different words, which is dog and fish. So which cannot be possible, hence we'll return false. Let's see another case where we would understand why there is a need to maintain this set. Okay, so instead of this last value, we'll take suppose D as dog. So in this case, A and D, two letters are being mapped to the same word, which is dog. So let's see how to check whether there is one-on-one mapping between them or not using hash map and hash set. So first we'll traverse A and we see that this is not present in hash map, so we'll add it to our hash map and we'll add this value to our set. Second time B is not present, add it to the hash map, add its value to the set. Third time B is present, we'll check whether this value of B, which is cat, is same as the value of B in hash map. Yes, it is same. So we'll proceed further and we'll traverse this letter D. So we'll check whether D is present in the hash map or not. So this time D is not present, but before adding to the set, we'll check whether the value of D is present in hash set or not. So our value of D, which is dog, is already present in set. That means it is being mapped to some character. So hence, in this case, we will return false. In this case, we will return false. So what we are doing in our approach is first we are checking that if our character is present in map or not. If it is present in map, then we'll check whether whether this value is same as the value of character in map. For example, B was already present in our map and we have checked the value for B, whether this value is equal to the value which is present for this same character. If it is not equal, so if it is not equal, then we'll return false in this case. If the character is not present in the map, then we'll check else. If the character is not present in the map, then we'll check whether this value is in set or not. If it is already in set, that means this value has already been used by some character. So we'll return false. So if the value is already in set, we'll return false. Else, what we'll do is we'll add it in our map and set. Also, there is one thing which I need to point out, that we can also maintain a hash map, another hash map, instead of maintaining a set. So we have maintained a hash map and we have maintained a hash set. So instead of maintaining a hash set, what we can do is we can maintain a hash map in which we can maintain a string and a boolean. So for each string, we can add, suppose dog. So for each string, we can maintain a boolean flag whether it has been used or not. So we can add true in this case, and we can fetch the value for dog. If we get the value as true, that means it has already been used. Otherwise, we'll add it to our hash map. Okay, so now let's move on to the code. So here's a function given to us, word pattern. We are given a pattern and a string s. So we have created a hash map of character and string, which is map, and we have created a set of string, which is word set. And first thing we need to do is we need to split the strings because our string contains spaces in between: dog, cat, and dog. So we need to split our string. So we need to split our string around each space. So this is what we have done in this step. We have added these words in a array of string, which is str. Okay, first thing we'll check whether the array of string and the pattern, these lengths are equal or not. If it is not equal, then we'll return false, else we'll proceed further. We'll traverse through each letter of pattern and we'll store each letter in character ch. Firstly, we'll check whether our map contains ch or not. If it contains ch, then we'll check. If it contains the character, then we'll check whether the value for that character is equal to string of I or not. If it is not equal, then we'll return false. And if our map doesn't contain character, now we need to check whether a word is being mapped to some letter or not. So we'll check if our set contains that word or not. If the word is already present in a set, that means the word has already been mapped to some letter, and then we'll return false. Else we'll add our character and word in map and we'll add our word to our word set. And after that, when all the traversal is completed, then we'll return true at the end. So what is the time complexity in this case? So we are traversing each letter of pattern. So we can say time complexity is big O of n, where n is the letter of pattern. So the time complexity is upper bounded by n because there can be a case in which we may return it in less than big O of n also. For example, if there is a case like a dog and again a cat. And suppose there are several other letters in a pattern and we'll return false at this particular step. So time complexity is big of n because in worst case we might need to traverse whole pattern. What is the space complexity? We are maintaining a hash map and a hash set, and in worst case there can be n number of letters in a hash map. So space complexity is also big of n. So I hope you have understood this. If you have any kind of suggestions, please comment it down. Thanks for watching. See you in the next video. Bye for now.